Alright, this is homework 1, problem number 18. It asks the question, a sound source is located somewhere along the x-axis. Experiments show that the same wavefront simultaneously reaches listeners at x equals -7 meters and x equals 3 meters, right? So given what the two points are, you can just visually graph this x-axis, y-axis, y-axis. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, -7. So these are 2 points. It asks the question, what is the x coordinate of the source? So you have this equation, which is the phase difference. So phase difference equals 2 pi delta x over lambda. This also equals phase 2 minus phase 1 equals 0, which equals 2 pi r2 minus r1 over lambda. So you have these two, and you set it equal to each other, right? And when you do, you get r2 minus r1 equals 0, because the 2 pi and a lambda will cancel each other out. So then you bring r1 over to the other side, which equals r2 equals r1. And this basically means that the middle point, or the source, will have to be in between these 2 points. So then that would be right here at -2. And this would be the source, where the source is at. And then for B, it states, a third listener is positioned along the positive y-axis. What is her y-coordinate if the same wavefront reaches her at the same instant it does the first 2 listeners? So what this means is the third listener is located somewhere along the positive y-axis. So let's just say it's right here. And as you can see, this makes a right triangle. And you know that the distance from the source to each point is 5, because 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that means this, the hypotenuse, will also equal 5. And you would just use the Pythagorean theorem to solve for y. So 2 squared plus y squared equals 5 squared, which then equals y squared equals 5 squared minus... Just basic algebra at this point. Squared equals 4.6 meters. So yeah, this would be where the y coordinate would be at for the third listener.